This video is one of several that we're making just to remind you of school, well, remind you of school days, I suppose. Remind you of the type of algebra and mathematics that you did in the distant past and which you may now have forgotten. So it's just worth bringing it up to speed, just going across it again. So many of the topics are very straightforward, quite simple really, but nonetheless important, and particularly important if you're coming back to education after a long break, just so you're familiar with what you did in the past and you're able to handle what we're about to throw at you. So this particular video, the one we've got in front of you here, as you can see, is subtracting in algebra. Now, that may sound dreadful, but in fact it's very straightforward. Algebra, you'll just remember, is a way of representing mathematics in letters. So instead of saying a fraction is, let's say, a half, 1 over 2, we might say a fraction is a over b, where a has got a certain value and b has got a certain value. And when you're at school, as a school child, you'll spend a lot of time trying to work out the values of a and b. And that's what we want to talk about. We want to talk about simple processes in algebra and bring it back to your mind so you have it ready. And we're not going to use it extensively on the courses, but it's just nice to know, just in case. So algebra uses symbols instead of numbers. Generally speaking, we don't use a lot of 1, 2, 3, 4, 5 and so on. We use A, B, C, D, and we use letters. And we're able to work out general principles using the letters, and these are equally applicable in the case of numbers. So the same processes, the same ideas, except one is letters and the other is numbers. We can use all the rules of arithmetic when we're using algebra. We can add, subtract, multiply, divide. So we can use all the traditional techniques of arithmetic. Nothing to stop us adding a and a together. We get 2a. Nothing to stop us adding a and b. We just get a plus b. So we can do everything that we do with numbers. We can do it with letters. Now let's look at adding and subtracting in algebra. Let's say we wanted to add 3x plus 6, and we're going to add 2x minus 2. Now we don't know what x is. X is some number, but we don't know what it is. In fact, that shouldn't worry us. It's just x. X could be 10, could be 100, doesn't matter. It's just x. What we want to do is to see how it works, to see if we can add using these type of representations. Let me put the cursor onto the screen. It's just a traditional computer cursor. There you are, nothing fancy. Now we're going to take 3x plus 6, this one here, and here it is over here, 3x plus 6. Add 2x minus 2. There you are, 2x minus 2. Now we're going to add this. So we add, always line it up carefully. Make sure your x's are under each other. It makes life not just neater, it makes it easier to see. So when you have something like this, try and get them added, lined up, so it's easy to do. Now we've got the x's lined up here. So we've got 3x plus 2x, well, that's 5x. There's the 5x. Now here we've got plus 6 minus 2, and when we add that together, we get plus 4. So when we add the two up here, we get 5x plus 4. We've just added in algebra. As you can see, there's nothing really difficult about this. It's very straightforward. very useful technique when we come to business and finance. We're able to represent quantities in X and Y and work out their values. It's useful. So let's not fight it. We can subtract the same thing. Here we're going to subtract 3x plus 5. We're going to subtract that from 5x plus 7. Now just write it down again. Line it up like I've done. Get the x's under each other. Get the numbers under each other. So top line is 5x plus 7. Subtract 3x plus 5. Here we are. 3x plus 5. Now subtract it. We'll do the x's first. So it's 5x, take away 3x, which leaves us with, surprise, surprise, 2x. And 7, take away 5, is 2. So when you subtract them, that's what you get. So adding and subtracting, very, very straightforward in this case. Now if we subtract, let's say we have 6x plus 8, subtract 3x minus 5. A little bit trickier, this one, but nothing we can't handle. Again, line it up. Line up the x's. Line up the numbers over here. Now write it down. We've got 6x plus 8. 6x plus 8 over there. So just write it down here. Take away, subtract 3x minus 5. 3x minus 5. Now when you subtract it, you get 6x, take away 3x, well, that's going to leave 3x. And over here we've got 8, take away minus 5. Take away minus 5. Note the minus sign. And when you have 8, take away minus 5, we get actually plus 13. Seems like magic. It's actually very straightforward what we've done here. So how do we get the 13? Well, when we subtract, we're looking for the difference between two numbers. That's when we subtract things, that's what we're doing. We're looking for the difference between the two. So up here we're looking for the difference between plus 8 and minus 5. So we're subtracting it. And what's the difference between plus 8 and minus 5? Well, it's 13. We got minus 5. We got 5 here. We got to take 5 to get to 0, and then 8. 5 and 8, 13. The difference between plus 8 and minus 5 is plus 13. So, for example, the difference between 6x and 3x is 3x. Just subtract them. The difference between plus 8 and minus 5 is 13. That is the difference. If we take away 8, we get down to 0. Then we've got to go to minus 5. Carry on. So 5 and 8, 13. And that's how we get the 13 up here. Six x plus 8, subtract 3x plus 5. That's what we get. Now we can check that that is correct. Let's say that x equals 4. We can make x equal any number, but 4. Why not? We could make it equal 5 or 10 or whatever you want. It should work out just the same. We'll just make it 4, just to see how it works. Now, here's our original expression. So we have 6x plus 8. So 6 times 4, x is now 4. 6 times 4 plus 8. Actually, if you just carry on to the next box, 6 4 is 24. 24 here, plus 8. 24 plus 8 over here. Next one is 3x minus 5. Well, 3 4s, 12 minus 5. 12 minus 5. And the bottom one is 3x plus 13. So it's 3 4s, 12. 12 plus 13. Now let's take this box here and just move to the last step. 24 plus 8 is 32. 12 take away 5 is 7. And 32 take away 7 is 25. So what we've got now is the solution to our problem above. The problem above was we needed to reconcile these two numbers to make sure that the answer down here was consistent, and that's what we've done. When we set x equal to 4, we've worked that across all the way. Again, x equals 4, so we're consistent. 3 times 4 minus 5, work it across, comes to 7. And the answer up here, 3x plus 13, well, 3 fours 12, 12 plus 13, 12 plus 13 is 25. And when you take 32 and take away 7, you also get 25. So our calculations have been correct. So you can see working with algebra is not so scary. It's quite a straightforward way of thinking. It's a very useful way of thinking. Just sometimes we don't know what the numbers are, just let it equal x, or a or b or something, and then we try and work out what is x or y or whatever it is. We just try to find the answer. What's the value, the real value, the number that's behind it. But we need to be able to manipulate the x's and the y's. We need to be able to go through algebraic expressions and manipulations. And as you can see, they are the same essentially as arithmetic operations: adding, subtracting, multiplying, dividing. That's what we're going to do in this short video, so let's leave it at that. As I said, it's very, very straightforward. If you find these videos are too simple or too basic for you, just forget them. Don't look at them. Carry on to do some of the more interesting videos for you. We've got loads of them on our course, and you have a program perhaps to study on the course. But these ones may help you to understand how to work out the basic laws of arithmetic and algebra and be able to apply these. Many of which, these techniques, you will have studied at school. And this is just very basic revision. But let's leave it at that and just say thank you for watching.